This section is navigating the CLI and introduces VRP. The implementation of Huawei devices in an enterprise network requires a level of knowledge and capability in the navigation of the VRP command line interface and configuration of system settings. The principal command line architecture is therefore introduced as part of this section, along with navigation, help functions, and common system settings that are required to be understood for the successful configuration of any VRP managed device. Upon completion of this section, it is generally expected that trainees will be able to navigate the VRP command line interface, configure basic VRP system settings, and perform basic VRP interface configuration and management. The startup of a device that is supported by the VRP operating system will go through a boot process similar to what is shown here, in which case information with regards to the status of the device will be shown, as well as other valuable information such as the version of the VRP image which is currently being used. And we can see that here in terms of the AR2200 followed by the .cc extension. Additional information includes the storage location of the image, which is shown as being SD1 here, and also the option to actually go through what is known as the auto-config process, which provides us with two options. The first is to follow the configuration steps for system setup. That means basically it provides us with prompts and we can actually use those to decide what settings should be applied. The other option is to actually manually configure the system setting parameters. And this can be done through the prompt we see at the bottom here, in which we are asked, do you want to stop the auto-config process? And if we do, we just basically give the option of yes or why. The architecture of VRP is considered hierarchical and involves multiple command views. The configuration of commands relies greatly on the command line being assigned to the correct view. So we demonstrate here some of the common views that users will often come across, as well as their role. We start off here with the user view, and this basically supports commands that display information about the system based on current parameters that have been set. From the user view, we're able to move into the system view, and the system view allows the configuration of various system parameters to be performed. From the system view, we have other subviews, including the interface view and protocol view. And of course, the interface view allows us to configure these interface-specific parameters, whilst the protocol view allows the configuration of protocol-specific commands. So we see an example down at the bottom here in the case of the parenthesis showing as chevrons, which represents that we are currently in a user view, and how we can actually transition into a system view. So once we use the system view command, we can see that these parentheses change and become square brackets, identifying that we've actually moved into a system view. From here, we can use the command interface gigabit ethernet 0/0/0 to actually move into the interface view. And this is actually represented within the parenthesis once again. In terms of navigation, VRP offers shortcut keys that can be used to simplify navigation of the command line interface. Such shortcut keys enable navigation such as moving forward or backward, deleting a word in a command, or even deleting a whole line. So we show some examples here of certain commands that can be used, including Ctrl-A, which moves the cursor to the beginning of the current line, Ctrl-C, which stops performing current functions, such as in the case where maybe a pin command is being used. And we also have Ctrl-Z or Z, and this basically returns us to the user view. So we can see an example of that down at the bottom here, in which case we've actually transitioned to a system view from the user view, and we've used the Ctrl-Z here to actually transition back to the user view. And finally, then we also have this control and right bracket that is used to often exit from a connection, such as in the case of remote connections like Telnet. Some other command line interface functions that we are able to support include the backspace, which deletes the character to the left of the cursor and moves the cursor to the left, as we see with many other applications. Additionally, we also have the left arrow key and Ctrl-B, which basically perform the same function and moves the cursor a single character space to the left. Additionally, we also have the right arrow key and Ctrl-F, which will perform the same function but to the right. And then finally, we have the tab key that, as it mentions here, completes any incomplete keyword that is entered. And we demonstrate this down at the bottom, in which we have the keyword here of INTER or inter, which is not complete. However, we consider this to be a unique key, and once we press tab, it will actually identify the keyword of interface. So we're able to auto-complete the entered character string here. VRP includes help features that support user command line configuration and navigation. The help features come in two forms. The first is known as partial help, whilst the other represents complete help. In both cases, the question mark is used to define the help function. With partial help, the question mark is placed immediately after the entered word or character and will assist in providing a list of possible commands that match the entered string. So we can see an example of that here, in which D is followed by a question mark and gives a list of possible completions. When the command is followed by a space and a question mark, the complete help function is used and will list keywords associated with this command and a simple description of the function. An enterprise network is likely to have multiple devices, possibly of the same type, and so it becomes increasingly difficult to identify one device from another. So what we need to do in this case is to be able to actually specify the system name for each device to be able to uniquely identify the devices, and we can do that through the use of this sysname command. So we can see in this case we have to transition from the user view into the system view using the system view command, and from the system view command we are able to actually specify the system name using the command sysname, in which case we've actually changed the name from Huawei to RTA. The system also contains a clock function that is required to be set as part of the process of device commissioning. There are three main clock-based commands that may be used. The first is the clock time zone that refers to the current time zone in which the device is located. This by default is set to 0 based on the Coordinated Universal Time or UTC. It is recommended that this time zone parameter be set before the actual time is configured, since any change to the time zone will also result in a shift in the current time settings. In order to set the time zone parameter, we firstly define a name for the time zone, in which case we see here is BJ in relation to Beijing. Since Beijing is 8 hours ahead of UTC, the add command is used together with the 0800 parameter to create a time zone equal to UTC plus 8. If the time zone is west of UTC 0, the minus command should be used. The date and time are set through the datetime command, in which the time is set using the hours, minutes, seconds format, followed by the date, which uses the same date format as supported for Internet timestamps, as defined under RFC 3339 and ISO 8601 standards. There are also some regions which follow daylight savings time, for which the clock daylight saving time command is implemented to allow the time to shift as the daylight saving period transitions during specific times of the year. The display clock command verifies that the clock settings have taken effect. For users logging into the VRP operating system, certain header messages can be set to provide relevant information. This is commonly in the form of an authorization warning message to notify of access permissions. As we can see, there are two forms of header message. The first is the header login that displays messages on the terminal when the user is authenticated by the device, such as at the point of accessing the device through another means such as Telnet, which will be discussed later in this course. The header shell represents a second header message that is provided once the user logs into the device locally. The example shows how this is achieved, and the actual message is defined by markers, which allow the start and end of the message to be specified. In this case, we can see these to be speech marks. The resulting output shows where the messages are then output in the command line interface as part of the login process. The command line interface is also managed by command levels, which restrict certain users who are given access to the CLI the ability to use certain commands. There are generally 4 levels that are supported, which range from 0 through to 3. Each level supports a general scope of operation, such as in the case of level 0, which is known as the visit level. Access is restricted to running network diagnostic functions such as ping and traceroute, and a limited number of commands to display certain network information. As the command level increases, the permissions of the user become greater, allowing for more control of system configuration and access to more display information relating to system operations. The management level, or level 3, allows for full range access to configuration and information, which includes the ability to reset system and protocol-based statistics. These command levels and the commands that can be used under each command level can be altered. We show here the command privilege level, which allows the save command that is part of the user view, as was introduced as part of the command line views, to be only usable by users that have a user level of at least 3. This directly translates to a command level of 3, preventing users with a lesser user level of being able to implement the command. As part of the establishment process to the VRP managed device, we have introduced the console interface and how it is used to provide access to VRP. The management of the console interface, however, can be achieved through the console user interface. There is only a single relative number here, meaning that only a single console interface can exist at one time for one device. The virtual teletype or VTY interface is a second form of interface that allows multiple virtual connections to be made to the device from remote device via a connection over the connected medium such as Ethernet. This generally will support up to 5 virtual telnet-based connections from 0 to 4. However, this can be extended to allow up to 15 connections to a single device to be supported at any given time. There are certain parameters that can be applied for both the console interface and also any VTY connections made. These include the idle timeout, which specifies the period of time that a connection may have no activity before the connection will effectively close, and authentication is again required to gain access if a password has been set. This is usually set as a period of 10 minutes to provide some security to an idle terminal connection. As information is displayed on the screen, it is possible also to limit how many lines of information are displayed at any one time through the screen length command. Finally is the history command. This will keep track of the commands that have been used and allow a user to review or recall those commands as required. However, this is generally limited to 10 commands, but can be increased up to 256 store commands where it may be required. From the command output at the bottom, we can see how the user console interface is accessed using the user interface console 0 command. And from this console view, we can actually assign the history command, as we can see here, in which case we've specified that we want to increase the history command max size to a size of 20. In addition to that, then, we can also specify an idle timeout here, and we've done so specifying a duration of 1 minute and 30 seconds. As part of providing access via terminal interfaces, the level of authentication applied can be set by applying a password that is associated with a certain privilege level to the interface. If we follow the example here for the VTY interface, which supports remote telnet connections, users that log in with the password of Huawei will be given authorization to access the device with a privilege level of 2, meaning that most commands can be configured. However, some sensitive commands are generally restricted to this range of users. This provides a general means of controlling user access, however does not make clear which user is accessing the device, which may pose as a security concern. It is also important that we understand how to configure IP addresses within the command line interface of VRP, and we demonstrate that here. Well, we start off by looking at RTB and wish to configure 2 interfaces or IP addresses here. The first is the 10.0.12.1 IP address with the /24 prefix on interface gigabit Ethernet 0/0/0, as well as an IP address of 1.1.1.1/32 on the loopback interface 0 of RTB. So we can see how that is done here. We start off in a user view and transition into the system view, from which point we can then also move down into the interface view via the command interface gigabit Ethernet 0/0/0, where we actually go ahead and configure the IP address using the IP address command followed by the IP address itself and the subnet mask. With the loopback interface, we show an alternative method, in which case here you can see we actually use the interface loopback 0 command to move to the interface view for the loopback interface, following which the same IP address command is configured for 1.1.1.1, but instead of using the subnet mask, we are using a prefix here of /32. In summary, we have 2 questions here. The first is, how many users are able to connect via the console interface at any given time? Well, if we recall, the console interface only provides access for a single connection at any one time. For support of multiple user connections, the VTY interface should be used. Secondly then, what is the state of the loopback interface 0 when the command loopback interface 0 is used? Well, the loopback interface as a logical interface is always initiated in an active state that is shown as up in any interface display information. It is also possible, however, that these interfaces be shut down if necessary.